Today's goal is to find the vertical asymptotes of a rational function. So keep in mind a rational function is a ratio, a fraction that has polynomials in the numerator and denominator. So it might have linear expressions, quadratic, cubic, degree 4, degree 5, whatever, in both the numerator and the denominator. And an asymptote is a line you get really close to, but probably never actually intersect. I think the best way to understand vertical asymptotes is to look at this parent rational function 1 over x. And by parent, we mean the most basic example. Okay, it's doing nothing terribly interesting a lot of the time. Okay, we can fill out a lot of these values and we can start to graph, okay, at the x value -3, it's -1/3, and then it's a little bit bigger at -2. And then at -1, it's the y value 1. Okay, nobody cares. When you try to substitute in 0, in your calculator, you're going to get an error. You cannot divide by 0. Think about division like Halloween candy. If you and your siblings all go and get a whole bunch of Halloween candy and then you divide it up amongst you, you can divide it amongst 2 people. Everybody gets half of the lot, right? 10 pieces of candy means everybody gets 2. You can divide amongst 3 people. If you get 15 pieces of candy, everybody gets 5 pieces. You can divide amongst 1 person. So if you get 20 pieces of candy, you get to keep all 20 pieces of candy. But what would it look like to divide by 0? It wouldn't be 20, that's just dividing by 1. You can't make the candy disappear or share it with 0 people. It just doesn't make any sense. Okay? And what happens when you get closer and closer to that x value 0 in our parent function? Well, let's see. 1 divided by -1/2 is the same thing as 1 times -2 over 1, so that's -2. 1 divided by -1/3 is equal to 1 times -3 over 1, so this is -3. And if you choose x values that are even closer to 0, you see that the y values decrease dramatically. Got these in the wrong quadrant, don't I? So for the x value -1/2, we're at the y value -2, and then they get closer and closer and closer and closer to the y-axis. This is creating our vertical asymptote. You'll see that the same thing is true in the first quadrant, except that those y values get positive. They get much, much, much bigger. So vertical asymptotes come from trying to divide by 0. Because when you divide by a number that's closer and closer and closer to 0, those y values will very quickly increase or decrease. Let's take a look at a couple of examples. Okay, the vertical asymptotes are coming from the denominator. We cannot divide by 0. That is x minus 4 times 9x minus 2 can't be 0. We don't even know what that means. It's called undefined because there's no mathematical definition, meaning it's just nonsensical. There's no real world analogy. You can't take 20 pieces of candy bars and physically divide them by 0. It just doesn't make sense. So x cannot be 4 or 2/9. If you didn't want to do that in your head, no problem. You can add 2 to both sides. 9x can't be 2. Divide by 9. X cannot be 2/9. If I asked for the domain, meaning what x values can you use, it's everything else. If I'm asking for the vertical asymptotes, like where are you going to have these places on your graph where the function shoots way, way up or down, the vertical asymptotes occur at the vertical line, x equals 4, and x equals 2/9. Let's take a look at this second example. This one asks for all asymptotes. So a little bit of review here. Let's think about the horizontal asymptotes. Well, I'm thinking about the degree, or the highest power of x, in the numerator and the denominator. And it's a little hard to see if I'm not putting my terms in order. Then I notice that the numerator and the denominator both have a degree of 3. So the horizontal asymptote will be that ratio of leading coefficients, 2 over -1, which just reduces to -2. So my horizontal asymptote is y equals -2. My vertical asymptotes come from the denominator. My vertical asymptotes are the places where negative 1x cubed plus 9x are equal to 0, because we can't use those x values. Well, it's a little hard to see what's up until we factor out the greatest common factor, which would be negative 1x. And then, of course, we need to keep factoring, because you can further factor x squared minus 9. So this function has 3 vertical asymptotes. One where each of its factors is equal to 0. Not sure why this one worked. You can actually just set it equal to 0 and divide by negative 1. That's where the asymptote x equals 0 comes from. So a rational function will have the same number of vertical asymptotes as its degree. Take a look here. This was a quadratic denominator. That's why it had 2 vertical asymptotes. This is a cubic denominator. That's why it had 3 vertical asymptotes. Okay, last example. Find, again, all asymptotes. So horizontal asymptote, I'm thinking about the degree. That's the unwritten exponent 1. Of the numerator, there are no x's in the denominator, so the denominator is degree 0. Keep in mind that if the degree of the numerator is bigger than the degree of the denominator, there are no horizontal asymptotes. We would say that the horizontal asymptote does not exist. Well, what about the vertical asymptote? Vertical asymptotes are coming from places where the denominator is equal to 0. Well, 6 is never going to be equal to 0. It doesn't make sense. So for the vertical asymptote, it also does not exist.